Hello everyone, welcome to MGC Manufacturing. I'm glad that you are here. I'm a little bit excited to be hosting you, and my name is Tlou Mokobodi and I'll be your host. We are going to run through some small logistics around the model of teaching for this year. So maybe we'll take it from there, then we will see if we are all comfortable. It's a pity that I won't be getting any responses from you guys in this video, but it would have been nice if we were in a session where we could speak like that, but probably in the near future we'll be able to achieve that. So the module is sliced into 3 parts. We have drawing, CAD, and then we have manufacturing. We have Rian, we have Isaac, we have myself. I'll be responsible for manufacturing, and generally on a weekly basis you're going to meet me at lecture number 3 for 110, but MGC 110. So with that said, we can maybe just run through some logistics. Please note that the time slot for lecture sessions will be used for consultation live in campus. So I will be present for you guys during those sessions, and then because of COVID restrictions, I would really like you guys to try to figure things out before you even get to a point where you think something requires consultation, because we have a lot of students and we don't have enough time. Usually our lecture halls would accommodate capacity of around 600 students. Because of restrictions, we are down to a lot less, probably some are even at 78 or 79, just around that. So you can imagine that we wouldn't be able to accommodate you, but this is because of where we are currently. But I hope we will work together around it. If you have any questions that are module specific, don't hesitate to contact us. The best will be an email and indicate that it's for MGC 110 and indicate for other modules as well. I will advise you not to hesitate to look for help in any case. So just look for help if you need help, but try to sort it out yourself up until you can get to a point where you really think, now I do need help. Okay, so we will be doing manufacturing today, or introduction to manufacturing today, and from there we will go into details around this. Weekly you are going to get 1 manufacturing class, but there might be weeks where you won't get it, but those will be communicated and you'll understand them better when you get there. And after 2 years you guys are now allowed to be back in campus. Practicals, maybe let me just touch on practicals because those are going to be very important for you guys. This week's practical, week 1, you are going to submit a practical, but that practical we're going to use it only to check if you guys can submit on the system that we'll be using to submit. Please watch the videos about AMS Judicator. Isaac will be responsible for that, so just follow that process that he will. I think there's a video already for you guys to watch. Follow that so that you can be able to submit, but it's not going to count towards your final grade or anything like that, but it is mandatory because we want to sort out the issues around submissions this week before we start next week with actual practicals. What is manufacturing? We are jumping right back into what we are here for. This is introduction lecture. I'll be general, I'll be all over, and it would have been nice if you could interact, like I mentioned. What is manufacturing? Example of manufacturing products and design for manufacturing. What do you think of what I'm about to say now? What I'm about to say now is just gonna cover everything. Manufacturing is a process of producing products using machines, using brains, using designs, using resources that you have. And example, computer is one of them, a pen is one of them, instrument box is one of them, a phone. Those are the ones that I'm looking at currently. A door, roof, a key. So there are a lot around us, and that is manufacturing. And basically we'll be covering processes, but in this module, because it's a mechanical engineering module, we will cover most of the products and processes that you find which undergo mechanical manufacturing processes. Examples as I was giving you guys, and then they become very complex. You can think of a paper clip, it's a manufactured product. You can think of an aircraft, it's a manufactured product. Many processes depending on the size of the product and requirements for the product, but really manufacturing is just there to answer to a question about what we need. It answers a question of the needs to support our lives at any given point in time in life. So you can think of manufacturing processes today are not the same as manufacturing processes 2 years back, 10, 30 years back, even in the first industrial revolution. So you can just look at it from that point of view. So we keep up improving them so that they can be adaptive and adaptable to what we need them to do. Today we have robots which we did not have many years back. So you can just think of that. We in the beginning of manufacturing processes, at least structured manufacturing processes, you can think of time before Industrial Revolution 1. There were still manufacturing processes, and then that is why we had to even come up with structured way. That's when we entered Industrial Revolution number 1. Now we are at number 4. You can read about that. Every part made by various processes undergoes manufacturing processes. It's manufactured. Basically, we are converting raw materials into products. If you can have a higher level of manufacturing, the standard of living is going to improve. Think of how we can be able to travel around now. We are able to manufacture airplanes, and for that, it's easier to travel. But in the past, you had to walk from here to Malelan, or from here to Cape Town, or from here to everywhere on land. We could not even go into the water and into oceans. Let me put it that way. Today we can travel across the oceans, through the oceans, or over the oceans. But really, manufacturing is the backbone of healthy economy. Healthy economy is what keeps us alive. The economy, if you go and find out the part and puzzles of economy, you're going to find that manufacturing plays a very huge role. Remember, manufacturing is not from only engineering, as I said there. That's why engineers are needed. But you can also have a situation where you also require other people, like artists. Let's say you have to manufacture a plane, a finished product, a plane. You need it to have an interior designed, which you don't need engineers, but you need artists. Each person contributing to a product will add a particular value to that product. Okay, let's move on. What is it? Like we said, you can have large manufactured processes, you can have small manufactured processes. The word product means something that is made or produced by some processes. And production engineering is often in the region of Europe or Japan. It's used to refer to manufacturing. Manufacturing is a complex activity. I just mentioned now about an artist coming to design an interior of a plane. Think of their requirements, and you need a whole lot of resources to work together so that they can produce the products that are helpful. Think of it: support services, purchasing, process planning, shipping, product control, product design and development, marketing, sales, even manufacturing itself. You need resources, materials, capital, energy, and people. They form an ecosystem of manufacturing. Here you can see manufacturing must adhere to the following aspect. You need to have design parameters and you need to have specifications. What are the parameters and what are the specifications? If you need to jump 1 meter and then you want maybe a spring product that can help you to achieve that, you need to indicate that this product needs to achieve a range, and then if it's in meters, height, or in length, you specify that. Those are specifications. And parameters: it must last for so many years, it must use this type of material, and the design parameters and specifications actually talk about more or less the same thing. It must be produced in the most economical manner. You don't want to be wasting time and wasting resources producing one thing. If you can produce this pen in 1 minute using 100 grams of material as the optimum, let it be like that. Don't find yourself in a position where you have this huge pen and you could have done it using less material. Time constraints are what we are constantly looking after. Budget, you are constantly looking after that. That is project management. Quality must be built into a product. This pen must last, this is a pencil. It must last for quite some time. And for that, you need to design things in such a way that they last. So you don't want to be having a pen that, I'm now thinking of those pens that I usually encountered at some point in my life, where the pen wouldn't write, even if it's new. It is frustrating. So there's no quality there. So you have a pen that you don't know if it's gonna write or not. That type. So there's no quality on that type of pen. But you can also see with the pricing on that pen that, okay, here we are talking about we have a problem here. Okay, but quality can speak about a lot of things. Strength is quality, beauty is quality, depending on who is looking. So production method should be flexible to respond to market changes. So you want to have a production process that can respond to the different needs. When I think about it, just think about industrial revolutions and how we progressed over time. So probably there was a time in life where we needed manpower. By manpower, I mean where we needed people to work, right? Currently, you might have the same work, achieve the same work that you achieved then with 100 men or with 100 people. Let me use people rather. You only need an operator for that machine that can achieve the same work. So it's adaptability and flexible, responding to the market. New development in material production methods and computer integration must be followed up to ensure product is produced in a most efficient way. This part here links back to the economical way. Same thing. Manufacturing organizations must constantly strive for high productivity. That is business now. Optimum use of all its resources, People should be on par. Machines should be well maintained. They should be well running. Energy, we need to have enough energy to produce. Machines should be provided with energy, electricity, as we need to have food. So you can understand that when we're speaking about manufacturing, we already, just that I touched on food, we already in the agricultural space, which there is manufacturing also going on in there. So you can think about it that it does play a role everywhere where there are products. We should always look at greater scheme of things. This is where now it brings about things like your environment, the planet, considering environment, safety. You can start thinking that politics are going to be involved in here, job creation, sustainability, having products that can be sustainable. You need to look at, when you manufacture, it's no use manufacturing a component that will not be purchased because you did not look into a greater scheme of things. The customer, are they willing to pay for that, this type of things? But we are going to cover a lot of these things that I'm speaking about later on in the module. Example that I gave, paper clip, think about it. Think about that. While you think about it, let's look at it now. Paper clip design. The material, should it be plastic or metal? You know which one you can use depending on the use, of course. How thick? What are mechanical properties that we are looking for? Strength, stiffness, the shape. The shape also tells you if it will work. Think of a spring. A spring, initially it was just a wire, but once you put some coils to it, it performs different functions. So that is the shape, where shapes comes in. Think of a plate. Once you think of this page here, and let's say it was laminated or something. If you have it like this and you just pour water here, it will just go everywhere where it wants to, depending on the. But once you do this, shape it, you might be able to pour water here and put it in this direction. Let me just put it in this. Pour water here, and then you get it here. That is transportation. That is piping. Another way of thinking about it. So transportation of fluid. I'm just giving an example as it comes because I said I'm going to be general as possible. Surface finishing. Those are things that now if you need to have a smooth surface or rough surface, think of your I'm thinking of a tar road. What you need there, depending on what the surface you need, the application. Think of your piston. Piston has to be very fine because cylinder and piston, you don't want leakage on the side because of roughness, those type of things. Some of the things you need fine surfaces, some you need rough, depending on application. Shape, we spoke about it. The method of shaping it. Shape, what shape is it and what method? Cost consideration, we just spoke about it. Style, texture, corrosion resistant, those type of things. During the production process, many questions are asked. These are not the only questions. Will the material bend without cracking? But the questions that we have here are from mechanical point of view. Will the cutting process produce smooth edges or burrs? Economical methods that we can use here, what are they? Who's going to buy this? How long will it work? Can we dispose it safely? What is the impact on the environment? How safe is it going to be? How sustainable? Maintenance wise? Those type of things. Another example, transistor. Here we are speaking about small things, very small things, microns. We are speaking about the thickness, less than the thickness of a pencil, and you still need to be able to touch on those. So there are processes already. We are at the microscopic level here, electrons. So look at this. This is how big this transistor is. And it has functions. Most of these chips, you find them in our computers, in our phones, but we are there yet. We just need to learn and know about these things and develop them further, because at some point you can imagine there was a phone this big. Now you have a phone this big. Start thinking about those, and this thing is because of they undergo development and redevelopment, so you get to improve them based on the requirements. Of course, the other requirement why phones are decreasing in size is because we want to carry them around, and at some point we had to have them all stationary like this one, because we did not have technology. They were supposed to be connected to function, but now we have phones that can work without connecting them to a physical wire. That's good. A bulb, we all know bulbs. A lot of processes have gone through that. So products like this, you don't think about them into such greater details, but they are actually products which are formed from manufacturing processes. That is the process, how you would go around it. There's automation of how this is going to be achieved. In the past, probably I would like to think we first had to use our hands to connect them. Currently, probably you don't even touch the machine which produces this. You only touch the light. And thinking about it now, you might be in a space, or we might actually soon be in a space where this product, we will only touch it when we have to install it in our homes, or when we take it from the delivery guy, or it might be delivered by a car or a robot or a drone. Those are the processes. They make our life easier, and then we touch it when we install it. If you are lucky and you designed a robot in your house to help you with a few things, you will maybe have a robot that will install it for you. I mean, if it can be produced from, let's say, the material used here were mined, we might be in a situation where the products are mined and then it goes undergo process, and then we deliver them to a factory where some of the components are produced, and then we put it assembly belt, all automation, and then the next thing we package it automated, transport it automated, and install it automated, something like that. When we dispose it, we could get to a point in life where it is there that we don't even have to touch it after disposing. And recycling processes. An engine now. We spoke about 4 million parts that goes to a plane. Think of this engine now. This is a jet engine. It requires more. So you can think of a light, it doesn't need more processes to go through, but this, you need a lot of components, bolts and nuts and sheets and turbine blades and a lot, and processes that check maybe how the quality of each product, will it withstand the pressure, will it stand the temperature, or the operating conditions, or even upset conditions where you have conditions that are not within the design. So there we will speak about safety of the design, safety factor. So you design something thinking of the day in which it might encounter a bad case scenario. It must operate still. Okay. Design for manufacturing. Okay. You need to have a design and manufacturing, which is a process which you can iterate. So it mustn't be a standalone type of thing. You must have designing phase and manufacturing phase, which you can be able to check. But we are constantly doing this, if you realize, because initially you will have a car that can do 100 miles per hour or 100 kilometers, let's use kilometers per hour. And after you touch there and here in the design, that car can now do 120, something like that. You should never separate the two. They should work together. Sometimes manufacturing engineers are called design engineers. So you must think about it along those lines. Okay. You must meet the requirements. Imagine I say design for me a pen that can last for 2 weeks if I write every day, and then probably I tell you how much I write and that type of thing, and you give me something. The reason for that is because maybe let's say I spend 2 weeks in a place where I'm far away from getting a new pen, and then you go design something that will last me a week. That's gonna frustrate me. So you need to make sure that you design something that can last as per requirements and specifications. That is the customer. We are actually designing to ease the life of the customer. In return, we also have our own, as designers, let's say as engineers, we also have our own requirements, of course, that we need from other guys outside our space, making everyone equally important for specific task and purpose that we serve. We must manufacture economically and easy. That is the process that you need to understand. We need to be very economical and we need to be easy in that. So if you can use a punch to get a hole, do that. It's easier. Just punch it. Otherwise, you can use a scissor, which might take time. And time, if we take it down, we might find that you are spending more time, and that's apparently a component of economy, because it links. Most people actually, when they get paid on rate. So there's the rate links money to time. So you will find that this person earns about let's say 100 rand per hour or 100 rand per day. You see, so we linking time and economy there. Okay. Designer must have fundamental understanding of characteristics, capabilities, and limitations of material, manufacturing process, and related operations, machinery, and equipment. You cannot design using, let's say, stainless steel if you don't know its limitations and properties, if you don't know its cost, if you don't know which machines you're going to use. So you need to have the understanding of a lot of things in order to say you can design something, which is why you don't have one person designing an aircraft, because we need all of us. Because otherwise, if you were given a task to design and build as an individual an aircraft, you would probably take, let's see, I don't know, you wouldn't even finish before you die. So think about it along those lines. You need to know the characteristics of material, capabilities of those material processes, operations, machinery, equipment, who you are designing for. And you also need to know something that I didn't mention here: legal implications. You cannot be going in and designing a car that cannot stop. I'm just giving a bad example here, but so that you can get the aim behind understanding a lot about what you are doing. So safety concerns, you must know who's going to operate this. If it's going to be operated by a child, let me give that example. You need to design it in such a way that you can think like a child. Otherwise, you're going to design it such a way that one day when your child is using this product, they get hurt because they didn't consider something. So you need to be, it must be, if it's going to be used by somebody with experience of a child, you just need to be able to look into safety. Otherwise, if it's going to be used by somebody at your age, tell them that don't do this. If you do this, this is going to happen. And then you confirm that you receive that information then you go on. Basically, that is what we get in the industry. You will be told what to do and what not to do, and then you sign saying that I received this training and I'm going to do what I have to do and not do what I don't have to do. Okay. The impact of engineering. Okay, some of the things I'm gonna repeat themselves here. Safety, assembly, production cost, and society, that type of thing. Don't want to design and build something that is going to affect our lives negatively in the society. We are in South Africa. One of the things that we have is that I think it's a problem, actually, global problem, adapting to technology. Maybe if we do adapt to that, we might, in a process, have people losing jobs. As one of the things, the impact that you might have, you need to keep in mind creating jobs. And there's a lot of things that we can talk about when we're saying impact of manufacturing, which we must keep in our which we must keep in our heads when we do the designs. Okay, now computer aided design, manufacturing, and process planning techniques are now powerful methods that we have, which we can use to help us in the manufacturing processes. Remember, we said is at the beginning. You need to be able to do rapid prototyping. If we have computers, we can visualize what we need, and then if we can go produce exact same thing that is designed in the computer, we can have prototype. You can imagine in the days where they did not have softwares to draw other things, like let me think, where they did not have softwares to draw a piston and a cylinder. Basically, you have to manufacture the piston first or the cylinder first, depending where you started, and then come and manufacture if you started with the piston, you will come and manufacture the cylinder. Make sure that they match each other. Think of the days where measurements were not taken serious. If you go into the history of measurements, you're going to find that at some point in our development as human beings, people used their body parts as measuring equipment. So if we agreed that we are going to use a hand, at least that's a first step. And then and say we are going to use the age and the hand. So we say if this person is 20 years, we can use their hand as a measuring tool. But you know how many variation in hands of the 20 years old are out there? So in some point, people use such methods. Now, when we invented a measuring tape or measuring equipment, we started saying a stick, having a stick as our measuring equipment. So we say this is a stick, we cut you the same length of stick to go manufacture with it. At least we were trying to get control. So rapid prototyping. The layout of a typical manufacturing process from the mechanical point of view: design process, selection of material, selection of manufacturing process, assembly line, product quality, automation, and the impact of computers. These are developments, and in the layout, of course, economics and manufacturing, organized for manufacturing. And this layout is not step by step. So you might find that economics of manufacturing will take place somewhere in selection of material, because you want to select economically the materials that you want to use based on the requirements. Say you want something that will break after use. Each time after you use it, I'm thinking of something now. Do you know that a fire extinguisher, if you break the seal, it's broken? So you need to break it so that you can use it. Otherwise, if it's sealed, it means it still has something. So that is the process and control over that. So you need to break it and use it, and then we know that it has been used, and then we refill it, or if it has some, we can reseal it or something like that. You don't want to go and for that and then use a very expensive material for that, because you know that part of it is to break it for use. Somewhere you don't want things to break, therefore you will not go and use a cheap a low strength material. Okay, let's go. The design process, and this process, don't look at it and say it's going to be step by step like that. Maybe some of the components of this process will remain. I mean, at somewhere up here, defining a product, this is where you get the requirements and the specifications. Concept generation, you might design and have a concept generation, then find yourself here. You might be somewhere here doing some drawings and find yourself having to having evaluation on the prototype testing because your drawings do not make sense or something like that. But it's iterative process. Think about it along those lines as well. Properties of material, they don't end here, they keep coming as we actually go into, when we understand material better. You have strength, toughness, ductility, hardness, elasticity, fatigue, creep, strength to weight ratio, stiffness to weight ratio. Manufacturing properties determine whether they can be cast, formed, machined, welded, or heat treated. Maybe let's not say manufacturing properties, but material properties determine if the manufacturing process can be cast, formed, machined, or welded, heat. I will teach you guys a lot about this in this module, so just keep that in mind. Casting, we have the expandable mold and permanent mold. Don't worry too much about it, just I'll go into details with that. Forming and shaping, we will cover machining, joining, and finishing operations. And because it's from mechanical point of view, just understand that I will I will be giving examples from mechanical point of view. Okay. Dimensions and surface finishing, I spoke about this a lot. Okay. Operational and cost consideration, it's very important. If this thing can be maintained, imagine having a car that you cannot maintain. Once it's broken, it's broken. You cannot substitute the parts, stuff like that. So you might spend a lot on cars each year after you have a breakdown. So you want to have simple things like tires. We know they get messed up very quick depending on how you drive, but you can replace those. And then as part of manufacturing, you need to standardize things so that you can interchange things. This is why I said, when I was giving an example about measuring equipment, that we started using sticks, then we invented the measuring tools like that. Availability of machines, you need to know if you can be able to manufacture this with which machines, where can I get those machines, number of parts to be produced. You need to cost consideration. If you can automate your process, it's fine. Tools and die are very expensive. Sorry about me just jumping up and down, but you need to consider these components. Be considerate. Be considerate about cost, operation. Okay. When you design, you must design for assembly, because some of the components, imagine you have a car that you don't assemble. It's a car, it's complete like that. You don't need to break, when you need to break it down, you need to cut it with a grinder or something. No, it's not an ideal way of manufacturing. Manufacture to design for assembly, so that you can break out parts, so that you can be able to bring plastic and attach it to a metal somehow, so that you can be able to attach electronics to mechanical components, that type of thing. So put that permit assembly with relative ease, possibility of designing a multi-purpose parts. Okay, if you can be able to interchange it, it will be very nice. Imagine each car or car model has a tire, but that tire can only be used on that particular car. It's not really nice. You want to be in a position where one day you need a tire. If it's identical model, design and everything, you can interchange some parts. Capabilities and limitations of each manufacturing process, accuracy and consistency. That is also going to be very important. We are going to touch on that. Assembly, look at this. We initially had this number A. We can achieve the same thing using number B, but these are different manufacturing procedures. If you don't have a procedure that can achieve this at a go, and then you have a procedure that can do this, then you are going to be forced to follow this method. And this can be a little bit expensive depending on the cost of each component here. Even here, it could be a little bit expensive because maybe the machine that you use to form this is expensive. Product quality. Quality has something to do with how satisfied you are after using something. High quality products function reliably as expected over a long period of time. Quality must be built into a product. We spoke about this. Quality control is very important. Automation and impact of computer on manufacturing. This is something that we cannot avoid today. Okay, major goals: integrate various operations to improve productivity. And remember, computers don't make silly mistakes like 1 + 1 cannot change, and they can do that repeatedly over 1,000,000 times within a short period of time. They can count from 1 to 1,000,000, counting each. Think of those machines that they use to count how many nodes you have. Probably they even take information. That machine goes right, and you can, in that process, the machine is able to detect even the numbers on the nodes. It's able to count how many nodes are there and which node conforms to which number. So it can record the numbers and record the number of nodes there. Think of that process. It's quick. It happens in a speed of a minute or something like that. Okay, minimize cycle time, reduce labor costs. This is basically if we could get to a point where this is achieved, we are all happy. So this is where politics come into the picture, and then if you need to think about it. Social impact, that would be a social impact. Okay, control and optimization of manufacturing because of computers, this I spoke about. Material handling, assembly, automated inspection and testing. You guys should see automated inspection and testing. Usually you would find me looking at the pen like this, checking if it has a defect or something, and then I'll take a minute just to check, and then that depends on how I feel, by the way. But once you have computers in the process, they will take less time and they don't feel anything. You preset them to know that, okay, if you see that there's a dent, then that product it's a failure product. You kick it out of the assembly line. With me, that day I'm angry or I'm happy, I look at the product, I see that it's a small dent or a big dent, or it's just on the edge of the criteria. So I get confused. When I'm happy, I just throw it, that type of thing. But remember social impact. So that's why we are dealing with it's manufacturing becomes very complex. And I just realized that was the last slide, and we have started with manufacturing, guys. Thank you for attending this session. The following session you'll see on your schedule for manufacturing, and then you can prepare by reading through the book. You can get the book and the details of the book in the study guide. I thank you.